Hello all, welcome back. When we talk about surface area of a solid, I'm taking a piece of paper. If I ask you to find the area of this one, immediately you'll say that area of a rectangle is the product of a length and its width, that is length to width. Yeah, now if I'm taking this rectangle, you know how to find the area of this one. Now I'm rolling this one, and I'm making like you can see that it's in the form of a cylinder. So can I say that if you see this cylinder, this is the curved surface area of the cylinder. Is that equal to area of the rectangle or not? I repeat, area of rectangle is equal to curved surface area of the cylinder. Well, so in such case, instead of this one, may I state that this one as a curved surface area of the cylinder is equal to, if you observe carefully, this is the length of the rectangle, but when I roll it, this one becomes like a circle. Agreed? Now this is the width of the rectangle. When I roll it, it becomes as you see that this is the height of the cylinder. Now this is not a rectangle, now it is a 3D figure. Now it becomes this part. You see that this part which was the width of the rectangle, it was the width of the rectangle. Now it becomes as height of the cylinder. Okay, just let me use my stapler. Okay, now now this is in the shape of a cylinder. You see that this is completely curved surface area. You see that this is the flat one that we will discuss a little later. So when we take the curved surface area, you have seen that the length becomes as a circle. So it is the circumference of a circle. Now this width becomes, you have seen that this width becomes as a height of the cylinder. As you know that circumference of a circle is 2 times pi times radius multiplied here height. So finally the curved surface area of a cylinder is 2 pi rh. Now if you are taking a cylinder, just now we discussed that this part which we call it as a curved surface area, this is a curved surface area of a cylinder, and this is a circle, and this is another circle. So if you want curved surface area of a cylinder, the formula is 2 pi rh. If you want total surface area, then here we have to include here this circle and the curved surface area. If you see this one, this is the curved surface area plus one circle at the top, one circle at the bottom. If you take so one circle here, and the curved surface area, which makes the total surface area. So I'm writing this one. It is this part is area of a circle, plus this curved surface area of the cylinder plus another circle. So area of a circle, you see that here one circle, so that area of a circle, and curved surface area, then the total gives you the total surface area. Now back to the point, area of a circle is pi r square, area of another circle is another pi r square, plus CSA. Just now we learned here that it is 2 pi RH. That one also I am taking. So pi r square plus pi r square gives you 2 pi r square plus 2 pi r h. This is the total surface area of a cylinder. Can you see something same in these two? Yeah, 2 is there. I can pull out as common. Pi is there. R square and R, I can pull R common. So 2 is taken as common, pi is taken as common. Out of R square, 1 R is taken. So you are left with 1 R, and 2 is taken as common, pi taken as common, radius is taken as common. So H is left. So TSA is equals to 2 pi R plus R plus H. There is nothing wrong if you can't memorize this particular rule or condition. There is nothing wrong. You can take that TSA is equals to 2 pi r square plus 2 pi r h. Usually I close my eyes and I'll think of the cylinder. When someone asks me that what is the total area of a cylinder, means it is CSA, which is 2 pi RH plus 2 circles, so that 2 pi r square. So usually I remember the total surface area as CSA of a cylinder plus 2 circles, which gives me 2 times pi r square. So there is nothing wrong. If you want, you can take this one, or else if you can memorize, you can use this formula. That's it.